All of you are AI users. I think not only all of you, everybody is an AI user now, isn't it? Only very few people can do business with AI and also run companies with AI. So today my aim is just to give you a glimpse how you can be that somebody. To do that, most important thing is you should know basically how AI works. And today I'm not going to explain you how AI works, but I will give you the key points and vocabulary, the basic things that you should know in order to properly understand how AI works. So that is the only thing I'm going to do today. Right. How many of you can say what is artificial intelligence? You are working with it, isn't it? What is AI? I'll ask a small question. This is Gary Kasparov. In 1997, when I was in year 5, he got lost to computer IBM's Deep Blue. Is this AI? Does this has anything to do with AI? How many of you think it is AI? How many of you think it's not AI? Just raise up. Only about 3-4 people think it is not AI. Yeah, it is not AI. It is just machine defeating intelligence. It's brute force calculation, nothing else. Very recently, Stockfish defeated AlphaZero. I think 10 years ago, isn't it? And then once again, Stockfish took over. So those who play chess knows that Stockfish is a brute force computer, and AlphaZero is an AI computer. So AI is not the best thing to play chess, whether it is artificial intelligence or natural intelligence. Brute force wins. So what is artificial intelligence? Yeah, artificial intelligence is, if I explain very simply, it is digital brains trained inside large computers. So I think all of you know now, large computer means not little bit large laptops like this. These are big machines like this, filling up several warehouses, one machine, and it takes sometimes more than one power station's power to run it. So they are trained in that, and seat of intelligence in animals has always been their biological brain. When it comes to artificial intelligence, therefore, the seat of it has to be an artificial brain. So it doesn't matter whether it is natural intelligence or artificial intelligence. Intelligence is based on one thing. The building block of it is, I think you know, it's neuron. So if you understand how a neuron works, you basically know how artificial intelligence works. So I'll just try to explain that in a very simple way. I think most of you know that, but for those few who doesn't know, I'll just try to explain it. I'll try to explain it in a very simple way. This is a father. This is father, and his height is x. This is mother. Her height is y. I want to calculate a system to predict the height of their son. Some doctors know it. So when you go to them, they will check your height and your wife's height, and then before you marry, they will say your children will be approximately this is their height. So there's an equation. So how to find that equation? What we do is we multiply x by a number. For the time being, it's an arbitrary number, y by another number. And then we do some mathematical function. Let's say our function we do is x plus y for simplification, and it gives an answer. This setup is simply a neuron. And let's think height of this father is 1 meter, not so all this much. And mother's height is 1. And W1, it's a number. I will take 1 for the time being, it is 1. And then W2 is also I will take as 1. So this is how it works. We will put it into the equation and we get an answer 2. Then we know his son, their son, this is their son. His height is not 2, his height is 1. So there is an error of 1 meter error is there. So what we do? We back propagate it. So when we know the error is 2, we can send it backwards to the equation and then calculate what is the right number for W1 and W2. So that is called training, that is called learning. So how it happens, I think most of you are engineers, so what we do is, this is not just a number, it's a function. So we do using the chain rule, we backpropagate, and this is what is called auto differentiation. So autodiff is the thing that gave rise to AI. So that mathematical system is now running the world. So AI is 90% it's auto differentiation. So only difference is when it comes to neural networks, it's not a single neuron, it's a network of neurons like this. So we have several layers like this. I think you know these things by now very well than me. To represent this, I will use this kind of a diagram. This is input, this is output, and the central neural network I will represent with this trapezium kind of a thing, then it's easy to understand. So I'm going to use that language. So how this is for engineers and people like you. For example, now this is a fluid flow. We want to determine what happens at the next stage to this fluid flow. Let's say this is a high-rise building, this is wind. How to use a neural network to determine this? What we do is we take all positions and velocities of all these dots here, all these molecules, and we'll convert them into vectors. Wait a minute, so that is, don't worry, that is usually what computers are. It will get better. So there are 7 dimensions we can think about. X, Y, Z are the positions, and X bar, Y bar, Z bar, those are the velocities and also time. So we can take each point and get these dimensions, put it into equation, and then we'll ask him to calculate whatever the outcome. And we get the real data, we do the real experiment, get the data, and then if this data is not matching, we will say, no, this is not correct, this is the correct answer. We back propagate it and try to calculate the W values. So that is how simulations are done, and I think all of you know this CFD simulations are now becoming, usually it takes several days for you to do a CFD simulation, but now within few minutes we do CFDs thanks to this kind of systems. Only problem is in this kind of engineering applications, you need huge amount of real data to train this. But there's a better way of doing it. Engineers has found it, and that is called pins, physics informed neural networks. So in the pins, what they do is, and we'll get an answer. So this particular answer has to be physically correct. For example, the mass of this thing, although we don't have measured data, we know the mass of this thing has to be conserved. The mass has to be conserved. The momentum has to be conserved. And the divergence of this has to be 0. And if it is a fluid flow, it should satisfy Navier-Stokes equations. So when you do that without measured data like this, we can say whether the output is correct or not. So we can, using it, we can train it backward. So with very amount of training data, you can train neural networks. So pins are coming at a big way in engineering applications, in fluid mechanics, heat flows, and you better study pins a little bit. Okay, so these are some other applications. For example, this is DNA sequences. So we had a problem. We know DNA sequence to convert to proteins, but how that protein is folded, how it is going to perform. So nobody knows how to do that. And that's what AlphaFold by Google did. So earlier we had understanding how one protein folds was one PhD. But AlphaFold learned all those data. It was trained the same way, and I think within a few hours they resolved 200 million proteins, and that is the entire spectrum of proteins known. So protein problem is solved. This will reflect in your medicine in coming years in a very big way. So that is how neural networks work. I think you have now a rough idea and you know what are the things to look at and how to learn things. But most important thing is language, isn't it? How to put language into a neural network? Because these things doesn't understand language, they understand only numbers. So what we do is we have to put numbers into tokens. One way is A is number 1, B is number 2, Z is 26. So we have only 26 tokens. You can put it in instead of A we can put 1. So that kind of way we can represent language. But that's a very small set of tokens and things will be very complicated. So that's not how neural networks work. They don't go by numbers, they don't go by words also. For example, architecture, archi will be this number, texture will be represented by this number. So these are called tokens. I think you have heard the word tokens in many times when you go to work with AI. So this is what token means. So tokens you can't just put to a neural network and then expect all the good things to happen. Tokens has to be represented in a multi-dimensional vector space. For example, this is a two-dimensional vector space. This is dog. So it can be represented in a point in this vector space like two numbers like this. So if it is a three-dimensional vector space with three numbers, you can represent it. So that is called vector embedding. So you embed data into vectors and then you feed it into neural networks. So that is how it works. So this is what is called embedding. So you will hear this word many times. So ChatGPT kind of neural networks, they have 60,000, approximately 60,000 dimensions. So it's a huge multidimensional space. And this number is now a world standard. It's not 60,000, it's a little more than that. But it's a fixed number. Because unless this number is matching, you can't go between different language models. So your dimensionality of your data has to be a fixed number in order to change between language models. So that is how language models work. And 2 years ago, IBM and several other companies thought an asset of a company like your construction company or a consultancy firm like ours is not people, it is going to be large language models. So they thought each company will develop its own large language model. So it can think like an engineer, it can think like a doctor, and that is the future. But there are problems. Now we understand it is not possible to do because it is far too expensive to train a language model like that. Plus, although you train it, how to update its knowledge time to time. So as the knowledge goes, you have to once again go and train it. So it's a very, very expensive thing. Except very few handful of companies in the world, large companies, nobody is doing it today. So that is not how companies work today. But there's a way. Many companies today work like this. Instead of training your own AI system, what you do is, this is your data and this is your inquiry. So if you want to ask a question, you take your data, take your inquiry, put it into a language model and it gives the answer. I think most of you now do like that when you come to ask a question with ChatGPT and so forth. If you have a PDF document, you upload the PDF document and then you put your query and it gives answer. The problem with this is, if your company's knowledge base is a huge knowledge base, all that knowledge has to be tokenized and do vector embedding of that each time you ask a question. So it's a huge problem and it wastes a lot of time, wastes lots of energy, so it can't be done. So that's why this system is now developing. It is called RAG, Retrieval Augmented Generation. So what we do here is, instead of putting PDF documents and so forth, your company database is converted to vectors and you have a vector database and you just feed that vector database. It is called RAG. You put RAG plus the query, the AI gives answer. So today, an assets of a company I think the belief of many AI companies is it's not people, it is not their own large language model, but it is their RAG. Any small company can develop their own RAG system today. It's very simple and you can do it. And also all of your companies have your own RAG. Use it to use it as the asset of your company, knowledge base of your company. So that is something possible to do today. Right. And then there's one more concept I want you to understand. It's not required for doctors and so forth, but since we are engineers and so forth, convolution AI. So language is one thing, convolution is another thing. I'm not going to explain what convolution is, but it is about vision. It's a mathematical system. So go home and then search convolution. It's a very interesting way of identifying objects. If you put convolution to this dog, it will trace all the edges and so forth. So just learn how convolution works. I'm not going to explain. So problem we had with vision, computer vision before AI is, this is a dog. So what computer can see is pixels. And if this is a rectangular picture, it will know the picture, the pixels and colors, and then how can this be a dog then for that computer? There wasn't a way computer can understand this is a dog and this is not a dog. It's totally different. The pixels are 100% different, isn't it? So even if you develop a computer to recognize this is a dog, how can this be a dog? Everything is different, but still we can see a dog, isn't it? Humans can see a dog, computer can't. And even if it recognizes this is a dog, how can it recognize this is not a dog? Very tiny little difference, but we can at once say it is not a dog, isn't it? So how to do this? And that is where convolution AI is come. It's very, very powerful today. So images are converted to convolution layers, and we feed it into CNNs in terms of numbers. And what we do is, the AI system gives an output. It will say it's a dog or it's not a dog. So if it says dog and if it is not a dog, what we will say is we'll back propagate, no, it is not a dog, and it has to calculate once again its W values. So when you do several times this, what will happen is it will develop a lower dimensional representation of a dog. In our terms, it's just a concept of a dog. So we have a concept of a dog. That's why we can see dogs. Right. So convolution AI are very, very powerful today, and even language models now all the language models, not only language, they have the convolution side as well. It is as big as the language side. For example, this is a question I have asked a language model recently. Looking at this photo, explain what is wrong with this. Most of you are engineers, isn't it? What is wrong with this? It's difficult for a computer to see because a lot of reflections are there, it's glass and so forth. But it's so powerful that it can see. This is what it said. A glass fin is meant to act as a continuous vertical stiffener. So this has to be a continuous vertical stiffener. And then splitting it right at that particular point does three bad things. And it goes on. It's the lack of moment continuity. So the moments are not continuous because of this particular break. And you lose the stiffness and load sharing you design for fin to provide. So it's not going to happen. And what will happen is potentially fatigue at the spider fitting above. Here there will be fatigue, and it will particularly say if there is high window, that kind of a situation, this thing will break and collapse. So I said that. I showed this to many engineers and they didn't say it to me. And it can see much more than that. You can't see this, isn't it? It says no proper gasket. So these locations, it says there's no EPDM gasket, and it says it is hard clamp, and that creates more stress, and therefore there's a huge threat of collapsing. Okay, can you explain what is there? What can you see? Is this some dust scattering on the road? Or is it car accident? How many of you think it's car accident? I showed this to an AI, and what AI said was amazing. It says the spread pattern of the glass suggests a significant vertical drop rather than a lateral flows like an explosion. It says something has vertically fallen, and it can be a glass panel, a large glass panel. And actually, it is the same panel 4 hours before. So this is at the 7th floor, as it said. It blown out with winds and it fallen into street like that and scattered the entire thing. So it's pretty much amazing what convolution can see. And if you don't believe me, if you carefully look at this picture, you can see the same spider web in here. Right, so today this convolution can do amazing things. For example, just looking at the retina scan of a person, it can detect diabetes level, the blood pressure level, kidney disease, liver disease, gallbladder disease, and Alzheimer disease, and also hyperlipidemia. So all that an AI can detect just looking at human retina scan, which no human doctor can do. And much more amazing things it can do, and in your field also a lot of things it can do. So better to know what convolution is. It is going to do a lot of things in architecture and also in engineering. Yeah, I'm pressing the wrong button, is it? Right. So those are some applications of convolutional neural networks. And then the last thing, can we run this neural backwards? Backward means we input the height of the son and neural network says this is the height of father and this is the height of mother. Can you do it? It's in a way it is possible uh, because one solution would be 2 meters father, 0 meters mother, but that is not probable, isn't it? There are no mothers of 0 meters high. one would be a probability. So considering what is most probable, it is possible to run it backwards. So that is what generative AI does. So we already have a concept of dog developed like this, and what we'll do is we will run it backwards and it gives out a dog. That dog is totally different to all these dogs. So that is what convolution does. This is what generative AI does. So generative AI can work, it need not to be image to image, it can be text to image also. So this is called transform architecture, and for example now this kind of girls I think you know see in Facebook many times, even videos, and they are not real. This is I think about 2 years ago, but today what it does, we can't recognize the reality and it's totally like real. So those are things transformers can do, but what are the things they can't do? Most important things we want, it can't do. If you do a sketch and convert it to a CAD drawing, uh, AI can't do it right now. Or drawing into a beam model, unless we interfere in a reliable way, we can't expect AI to do. AI can do little bit, but to be responsibly to a reliable level, there's no AI that can do it. So because these are not things to imagine and think, so these are not imagine and think, these are things to do. So that's why I start to talk about it. Drawing, CAD drawings, and then beam modeling, those are not imagination thinking. Beyond that, there's things to do. Menus is the most popular software of the AI system of doing things, but there's no AI platform that generally can properly do things like doing a CAD drawing. If you ask Menus, it also can't do. So the good news or the bad news is doctors and engineers, what is going to happen to them in near future? They have to die. They have to die. But the attendants and draftmen, I don't think AI can easily replace them, so they are going to survive. So that's the news. Whether you like it or not, that's the news. And that is because they do things. They not only think, they do things. So this is the topic of 26, 27. That will be the topic, AI to do things. Although I said there's no platform that can generally do things, AI can do specific things today, specifically things specific to your company. For example, answering all the telephone calls coming to your company, AI can do it. So that kind of a thing it can do. So there are a lot of things AI can do. And if your company can do things with AI, automation, and then your company is going to win in 2 years' time. So that's the reality. That's the thing you have to face. So how to get things work for your company? General AI can't do it. You have to work with workflow systems. So that is another word you should know. Workflow systems. There are several workflow systems, but the system that is open source, it's available for everyone, is N8N. Okay, so what I'm going to do is I will, instead of talking, we plan to do a demonstration how we have arranged to get certain things done with AI for a particular real project. That project is called Emerita. So he is going to demonstrate it. Before that, I'll explain what Emerita is. It's the first boutique apartment in Sri Lanka, and it's a design of a lifestyle rather than an apartment. The difference is this apartment's interior cleaning done by a company, and there's a 12-dish buffet, and there's a wellness program with jogging, gym, hot and cold water therapy pool, steam room, sauna, and all those things. And there's the regular health checkups of people. And because all these complicated systems are there, all these things has to be properly coordinated and resolve all these clashes that is possible. And it should be open to customization. So if the client wants clean his house right now, or if he says I don't want to clean today, I want to do it tomorrow, there should be option to immediately do the customization, and we have to respond real time. So there's huge amount of coordination works that is to be done. And then how to do it with AI. That's the task we had. So this is how it is done. There's an input coming like that. I think before that, it's better we'll show a little bit about that project. I'll show you some video while he sets it up.
Emerita, Emerita, it's the design of life we breathe. Emerita, Emerita, where moments linger to fade. Emerita,
we get back to the presentation. I just wanted to show that to you because one large property developer talked to me and said, we hired a vocal artist, we paid several millions for her, but your one is even better. Who is this artist? And that artist is AI. There's no single human involvement, even the music, everything is AI. Okay, so this is how the Emerita agent works. There's an input. Usually we use WhatsApp is possible, but we are using Instagram. And there's an AI agent there. And what this AI agent does is it has a brain. So this brain can be ChatGPT, it can be Google, it can be any AI model, and you can have several brains if you want. And there is undoubtedly the RAG, the entire set of training data. And then AI agents have tools. That's the most important thing. So with these tools, not only just talk, it can do things. For example, it can refer to Google Sheets, update Google Sheets, send emails, and all those things it can do. And our system is after doing all that, it has an output, and we convert it into voice. So this is usually how these workflow systems work. So it's a fun to work. So you can just plug things, remove things, and so forth. It's very easy. It's a visual language. You can try it out. It's N8. So for example, now in this particular project, we have created this kind of a bedhead console. It has stereo speakers. And then there's a particular computer called Raspberry Pi. It's a small computer gadget. So we have the main server where N8 is running, and it sends data through Wi-Fi to this one. And what this Raspberry Pi do is it switch on the this is the amplifier, switch on off amplifier, and then amplifier puts the voice back to the speakers, and you can hear. And if you want to answer that, one way is we can put a mic, but we thought to do it in a very sophisticated way. With your mobile phone, you can answer, you can type whatever you want, and it will go back to our N8 system. We use Telegram for that. So that is how this system works. And these tools are the most important thing. For example, let's say you order cleaning, so there's a cleaning schedule in Google Sheets. It refers to that schedule, it updates it, and it updates the calendars, and it also talk to humans and then inform them this is scheduled like that. So that is done through these tools. So that's it. So I think we want a volunteer, isn't it? Ginura, Ginura is the one who created the system. So shall we have some volunteer? Who wants to come? I think she wants to come, isn't it? So what it does is when he sends a message, it goes to the N8 system, and then it figures, it takes some time to work.
Good morning. I am Emerita, your exclusive lifestyle assistant here at Emerita Apartments. Shall we start the demonstration of how life will be as a resident here?
You can say yes.
Yes.
Now type it.
Wonderful. Before we begin, may I know your name? Please type it in the phone so I can personalize your demonstration. Hello, Hansha. I got back with the demonstration. Now, let's imagine together. Pretend that you are a resident here at Emerita. Let me show you how your day begins. Good morning, Hansha. It is 6 a.m., a beautiful Sunday morning. The weather outside is 26 degrees with a light breeze. Would you like me to arrange tea or coffee from the Fab restaurant today? Please type your choice in the phone.
So it's type, process the input and it goes to the agent. It takes some time because it has to use all these tools.
Hansha, I need you to please specify. Would you prefer tea or coffee this morning? Which one would you like me to arrange for you?
So he types something else, so it says. So that's the difference between a normal computer and AI system to understand. It takes some time because it's not just answering, it's processing everything. And
Hansha, it took some amount of time for me to get back to you, isn't it? That is because I am not a chatbot. I am a workflow that organizes and does things rather than just speak. By the way, excellent choice, Hansha. I've placed your order. Table number 6 will be ready for you at 7 sharp. Now, Hanshan, your wellness session is confirmed for 8 a.m. with your trainer. Would you like me to remind you in 20 minutes to change into your workout clothes? Just type yes or no in the phone.
so we'll just show that and then we'll stop it, but it will continue asking.
Understood, Hansha. Your wellness session with the trainer is set for 8 a.m. Now, may I schedule the apartment interior cleaning today? Janitors are available at 10 in the morning or 3 in the afternoon. Which time do you prefer? Morning or afternoon? Please type your preference in the phone.
If you like to type, so let me type, okay.
Thank you very much.
Yeah, so we'll stop there. So likewise, I mean, this system, what it does is it not only just talks, it organizes things, it updates the schedules, and it does the entire management of the system, entire management of the operation. So that is what you can do with AI today. And the thing with this kind of networks is it's a fixed network we are talking about. So AI can only follow this given paths. But now the next step is the AI is developing beyond that. So we have things like land graph where the AI itself arrange the network it requires to answer a question, and according to that it will provide answer. And the news is asset of a company in 2027 like is not its people, not LLM, it's not RAG, and it is going to be things like land graph. So that is where companies are going. So these are very, very powerful things. When this happens, it can do a lot of things. The AI can do things, and even right now it can be done. But you have to be very clever. You have to learn these systems, how to operate and so forth. But I suppose by 2 years' time, things will be simplified and AI will start doing a lot of things. Okay, so that's it. So that is my introduction to AI to do things. That's it. Thank you.
Come with the question. I will have a question.
Of course, don't put me in trouble as easy question.
So, conventional architect to architect with AI. So I see you are like architect with AI. So how you are going to differentiate it?
Yeah, putting me in trouble. uh, in architecture field, what I can see is still AI can't do much of things. But as you have been participating in my lectures, many lectures, I'm deeply into parametric design, use design things with the computers and so forth. The problem with AI is, as I told you, it uses to generate something. It uses the diffusion, the stable diffusion or diffusion systems. It's backrunning this what I showed, the convolution. So when it happens, it cannot generate something to particularly to the scale. If you ask, we have nano Madonna kind of thing these days, isn't it? If you type and explain something, you put a photo and then say generate something like that, it will generate, but it is not going to understand your context, not going to understand building regulations, not going to understand firefighting systems, and it is not going to generate something particularly to the scale. Uh, for some architects, you can use it as a tool to get refreshing ideas, for example. So if there's a project, you can just explain the project and it will provide a lot of beautiful images, and with that, you can use it as reference and do it. Uh, I don't do that, to be honest, because when I close my eyes, a lot of images come, and my problem is how to control that. So,
Good answer. I mean,
yeah.
that is again somewhere we are overtaking AI. Sometimes AI is overtaking human, but in this context, still AI is behind to human. In that sense, we are there.
Yeah,
So we go
in
with
that
that.
sense, yeah, in that sense, I mean, imagining something to scale, and it is actually all about doing things. That's the problem, I suppose. It's not just imagination, but AI can do wonderful things. So if I showed you what I did yesterday, it's working, still working, isn't it?
Yeah, yeah.
Let me, because you are not asking questions, I'll just show you. This is a project in Port City, and this is my analysis, how this to be done, uh, how many beach villas should be there, and then how many garden villas, how many apartments, and then area summary, and then calculation of parking, and then amenities and facilities that should be there in this particular project, all the list of services, then financial positioning, how much you must spend, what is your ROI, and the concept design intent. None of these are done by me. This is just ChatGPT. What I did was I did the Excel sheet with all these calculations that is there, put it there and ask them to generate a report, and this is what it has done. So one way is you can keep that question with your heart, and one day you can personally come and ask. So keep it within you. Fine. Okay. So we'll wind up. So to sum up, I will just tell few things. One thing is just don't be an AI user. Anybody is going to be an AI user, but be an AI creator. To do that, I think you have to do it as companies, although we are not AI experts. In our particular expertise sector, we have to do it. And then to do that, you have to understand how AI works. So that's the thing to take away point in my lecture. Okay. Enough, isn't it? Okay, so we'll wind up.